That. Changed it on me over midterms, huh? Threw a wild card in there. Now I'm all rattled. Quick review here. Three methods of proving triangles similar. Three methods of proving triangles similar. Here we go, 13. Angle, angle. Popular, popular. Others? There we go, DJ in the house. Didn't know. 15, another method. Side angle side, got to put the tilde in there. That distinguish it from congruent triangles. And the final method, 17. Yep, with the tilde in there as well. But when we're doing a proof, we only have to worry about what method? Angle, angle. That's the only possible method when proving triangles similar. All right, next review question. If two triangles are similar, if I know they are already similar, what do you know about the angles? No. No. Corresponding angles are going to be congruent. What do you know about the sides? They're in the same ratio. That's what you're going to prove to me today. Is in the proof statement now you'll see, show me the sides are in the same ratio. But I can't do that unless I know what about the triangles. They're similar. So basically, here's the nutshell, in a nutshell today. You're doing the CPCTC version of similar triangles. Instead of saying the corresponding sides are congruent, you're going to tell me they're in proportion. All right, so let's tackle number one here. Look at the proof statement first. I know some of you feel uncomfortable with that proof statement. What is it asking me? We don't usually write it this way, but we talked the first day of the unit. When I got the colons in there, that's the same thing as what? That's the ratio. So if you don't, hey, you don't like this? Before you start the proof, change it. FC over DB is equal to AC over PB. Again, you don't like the way that's written? Okay, change it then. It's still saying the sides are in a ratio. This is not going to be true. The sides are not going to be in a ratio unless I know what about the triangles. They're similar, so that's what I got to do first. Prove the triangle's similar. Ooh, that sounds great. Look at my diagram, though. We may run into a problem. Prove the triangle's similar? Anybody have a question they want to ask? Angle, angle. That's how we prove them all similar in a proof. So that's not really the question I needed. Thank you. Which triangles? I got a ton in there. I just pick my two favorite and go? No. I got to pick two triangles that contain what? These sides. That's how I'm going to find those triangles. So I'm going to take my first side, which is FC. All right, here's FC. I'm not confident yet on the triangles. Maybe you guys are. I'm not. So let me go to my next side, which is DB. Let me highlight DB. Ooh, do those two make a triangle together? FC and DB? No, those aren't full sides in a single triangle. All right, let me keep going. What's the next side? AC. Oh, okay, okay. Everyone see the first triangle that's going to be involved. Triangle AFC. And then go to the fourth side, PB. Okay. All right, I see you. Everyone see the second triangle. DBP. So use the sides in the proof statement to figure out the triangles. Okay? All right, we know angle, angle. Can you guys find two pairs of angles for me? And then we're done. Can you find two pairs of angles? I got an isosceles triangle. That'll probably get you something, something. And I got altitudes and perpendicular lines. Find the first pair for me. 4, got a pair?
Angle PDB is a right angle.
I'll stop there. Everyone agree? That's a right angle? Okay, put it in the proof. That's going to be a different reason from the other right angle, though. So why is that one in particular a right angle? How do we know to put that there? 7, let's roll. Perpendicular, yep, perpendicular lines form right angles. So that must mean there's another right angle there somewhere in this proof. 5, where's the other right angle? Yep, there it is, but for a different reason. Why is that one a right angle? 7, why? Definition of an altitude. Everyone all right so far? I don't want to go that fast. But you still got to say what about the angles in steps 2 and 3? Yeah, you still need angle. You still need an angle from angle, angle, so you got to tell me they're congruent. Right angles are congruent. One pair down. Where's the other pair then? Remember, we had not touched the fact that this thing was isosceles yet. Where's the other pair? 24, where's the other pair? Everyone good there? Those two? Angle B and angle ACB. Why? Here we go. True, but why? Justify. 2, why? That's fine. Yep, you can say it because it did give you as isosceles. We can also say in a triangle, congruent angles across from congruent sides. Again, if you want to put isosceles triangle implies base angles congruent, that's fine too. Do we have angle, angle? Is there anything else? Do we have angle, angle right now? Yep. So now you can tell me what about the triangles? Similar. Make sure you write the similar sign. Let's see, triangle AFC. Similar to, if I go AFC, PDB. Angle, angle. And now we take these proofs one more step. You're telling me the triangles are similar. Your sides are in the same ratio. FC over DB is equal to AC over PB. And it's, again, the CP-CTC version, but for similar triangles. Same rules apply. You want to use this abbreviation, it's got to be in the right order, right letters. Ready? Corresponding sides in similar triangles are proportional. Or write it out in words then, if you're worried about messing up the letter arrangement. CSSTP. There it is. Questions from you guys? One extra step here today. You guys are going to do a little more work on this next one for me. I tell you which 2 triangles to start with in part A. So right now I'm just going to walk around. I want to see you guys find the 2 angles in angle, angle for me. You know it's a parallelogram. I want to make sure you guys can find the 2 angles needed. before I say anything. Parallelogram to get another pair. Find another pair. All right, everyone's getting the vertical angles, which is great. But where's the pair from the parallelogram now? Think about your properties. We find the other pair. By the way, just looking at your assignment sheet, I apologize for putting the wrong date there. We're having the quiz on Wednesday. And also the clip art. Now that we're into the second semester, we know each other a little bit better. The clip art now will have a theme to it. It used to be just random in the first semester, the clip art, but now they'll have a theme to it. So what does whack-a-mole and Jenga have in common? What would be the theme? That would be games I will never, ever be beaten in. Whack-a-mole or Jenga. Steady hand, put that sucker right on top if anybody ever wants to challenge me. Whack-a-mole, don't even try. It is just zoned in. Boom, boom, done. Bell goes off. Sorry, you're done. All right. That's how I got, quick story, that's how I got that Hulk up there. Six Flags, you know, they have those carnival games. I don't know, kid might have been 7 or 8. Doesn't matter. Done. Go cry to your mom. All right, done. Okay, so whack-a-mole, there's no shot. I'm just zoned in. Zoned in. All right, where'd the other pair of angles come from? If that's a parallelogram, where'd the other pair come from? 14?
Alternate interior angles. DC's parallel.
Okay, that's the part I was worried about. You got to say before the alternate interior angle is congruent that you have parallel lines to do so. So I needed to tell you that DC is parallel to AB. Parallelogram implies opposite sides parallel. Got to have that in there. Now, did anybody go a step further and give me a little extensions? That's fine. That's fine. Yeah, that's fine. You don't need it, but it's fine. Both ways are correct, whether you said it or not, the extensions. And now, where are the alternate interior angles you needed here? If these are parallel, where's my alternate interior angles? Here you go, 20, where are they? Yep. Okay. Also, don't freak out. Don't change anything. If you didn't have those, you could have certainly had F and C, D, E as well. Both are alternate interior. Okay? So parallel lines imply alternate interior angles congruent. And then you guys have angle, CSSTP to finish this off. But had to have the parallel lines in there. That's what I was worried about. All good? You guys finish that? Go ahead, finish that one up, and then we are going hardcore algebra. Fire those calcs up. We're getting after it. Everyone good? Finished up? Okay, let's go hardcore here. AB parallel to CD, have to know that. Find x, and so I know I'm going to set up a proportion with the sides. Before midterms, we talked about this theorem called the side splitter. That if I have the parallel lines, it cuts the sides proportionally. Can I use that here? Can I use side splitter to say x minus 1 over 2 equals 4 over x plus 3? Side splitter? No. No. You cannot use side splitter with the parallel sides. Now, hey, I take 4, move it here, x plus 3, move it here. Yes, that's side splitter. Okay, you cannot split the parallel sides proportionally. All good? Okay, so I can't use it here. So I got to match them up correspondingly. So here you go. I'll take the easy way out. 4 matches up with x plus 3. Done. And I understand you guys may not set it up the same way I do. You may do 4 over x minus 1, and in the second fraction, match them up there. Fine. Fine. What's the other side in the triangle that's got the 4? X minus 1. Now you got to match them up. Here's where my concern is. What does x minus 1 match up with in the larger triangle? And it is not 2. All right, it is not. Settle down. Smart kids, settle down. What does the x minus 1 match up with? Let's go. 22, what's it match up with? I don't want to write that, though. Thank you. Don't write that whole thing in there, please. All right? Where did he get the x plus 1 from? He took x minus 1 and added 2, combined his like terms, and got x plus 1. Okay, please do not write this in the fraction. You're going to be like, what do I do? All right, freaking out, sweating. Then it gets awkward. All right, here we go. We're crossing them up. Here's where I start to get nervous. 4 and x plus 1 get multiplied. Here's my nerves. X plus 3 and x minus 1. You got to take, hey, you got to take your time. Distribute the x, then distribute the 3. Take your time. Showing off algebra skills. Here we go. 1. Right side, what do I end up with?
X squared minus 1x plus 3x.
Which combined to give you?
Plus 2x.
That plus 2x and then minus. Got it. Everyone good? That's what you should get on the right side. Get in here if that's a struggle, please. All right, everyone sees the squared term, so I'm thinking in my mind, get everything equal to one side equal to 0, right? So let's move over the 4x and move over the 4 for me. And then let me know what you end up with on the one side equal to 0. Move it all over. Move it all over. X squared, what else you got for me? Yep, 16, what else? X squared. Okay, great. We got the answer. That's all I'm worried about here. Okay, next. Factor time. 2 numbers that do what? Multiply to -7, but add to -2. I'll wait, and we'll keep waiting. Are there 2 numbers that multiply to -7 and add to -2? No, there's not. No shot. No shot. Okay? Which means, what's my only other alternative to solve this? Quadratic formula. Now, hey, whoa! Hold on. Yes, you notice that you can't factor. That's why you need to use quadratic formula. I also gave you a hint in the directions. Oh, everyone see this? Simplest radical form. Have you ever factored anything and gotten radicals in the parentheses? Me neither. So right away, when you read the directions carefully, oh, simplest radical form, probably never, ever going to be able to factor. So I've got in my mind already at the beginning of the problem, I'm going to need quadratic formula. which I will give you Wednesday on your quiz. Okay, just a reminder, x equals negative b plus or minus. So don't worry about memorizing it. It'll be on your formula sheet that I'll provide you on Wednesday. All right, I'm not allowing you to go yet. I need somebody to tell me what's the A, the B, and the C here. Value. Not variables. Just like I talked about slope on your midterm. They're numbers. They're not variables. So here we go. A, B, and C value. Somebody. 19. A value. Number out in front of x squared. 1. B value. Negative 2. And C. There we go. Now I'm ready to plug in. X equals. If your B value is negative 2, what's it going to become inside the formula? Positive 2. Plus or minus. You are not putting a darn number underneath there. How am I going to get that number underneath the radical? Store, store, store into your calculators. Do not store the entire quadratic formula. You're storing 1, negative 2, and negative 7 in for A, B, and C, and then you're just going to go b squared minus 4ac. I just want the number underneath. Do not store the whole quadratic formula in. And I'm hoping we all get the same value out. Again, you got to hit the number. So 1, store in for A. Negative 2, store in for B. And hopefully we'll all get the same number out. Whew. All calculators should be showing the same number right now that we're going to put underneath the radical. When you get your calculator to give you a 24, what's the number underneath? 28? You might want to check 1, negative 2, and 7.
Oh, wait, that's what I got, sorry.
Oh, now we got it, yep. 32, it's all over. 2 times 1, so 2. Directions again are what? Simplest radical form. Can I break down 32? If the answer is no, I'm good, but I believe I can. There's 32. And I know we have issues with this. Biggest, I know 4 goes into it. I get it. I know 4 does, but that's not the biggest. 16 is the biggest. So radical 16 and radical 2. Square root of 16 is 4. Bring the radical along for the ride. So that is what I'm going to replace the radical 32 with. 2 plus or minus 4 radical 2 over 2. Is it in simplest radical form yet? Oh, it's not. This denominator of 2 belongs to the left and the right side of the plus or minus. Here's what I'd like you to do. Cover up the right side. 2 over 2. 2 over 2. 1 plus or minus. Cover up the left side of the plus or minus. What can I divide there? 4 and 2 give me 2 radical 2. Now, whoa, that's in simplest over 2. The 2's are gone. Oh, don't pack up because that is in simplest radical form, but not my answer. Not my answer. Everyone still got your calculator fired up. Now look, these are 2 answers. 1 plus 2 radical 2 and 1 minus 2 radical 2. In your calculator, can you do 1 minus 2 radical 2? One of the solutions. Supposed solutions. Take that number right now and plug it in for AF. What's the issue? You're going to get a negative side. So even when you use quadratic formula, you got to worry about rejecting an answer. So this final answer will just be 1 plus 2 radical 2. I cannot count the negative one because it gave me a negative side. So that is it. Stop by today or tomorrow. Get in here.